So area of a segment, first of all, we need to figure out what a segment is. Since this is a sector, if we connect with a secant, the 2 points where the radii intersect the circle, okay, we come up with this triangle, and the segment is actually that space in between. Kind of be like cutting off the crust of your pizza and making a triangle with the rest. Okay, so we're talking about finding this area. So to break it down a little bit, if we took the area of the sector minus, sorry, this is a little off center, but minus the triangle, we get the segment. Okay, so area of segment equals area of the sector minus area of the triangle that we don't want. Right, so that is the big idea. So we're going to look at an easy one to start. So you're going to kind of do this in parts, okay? We just talked about how to find the area of the sector, so that would be all of this. So it's fraction times the area. So what would the fraction be for the part that we're talking about? 1/4, 90 over 360. So if you have those right angles, that's kind of nice. That saves you a little bit of time. So 90 out of 360, so we're going to go straight to 1/4 of the area, which is the radius squared times pi. So that would be 100 pi. So the area of my sector, 1/4 of 100, is 25 pi. Square the radius times pi. Okay, the triangle is 1/2 base times height. With a right triangle, with that 90 degrees, that makes it handy because there's base, there's a height. And you might initially think you don't have that, but you actually do because they're both radii, right? They're both 10. Okay? Since they're both 10, I can do 1/2 the base times the height. So half of 100 basically is 50. So 25 pi minus 50. Now, if you wanted the exact area, this is the exact area, because as soon as we multiply 25 by pi and round it, it's no longer exact, okay? So I'm going to just put a note here that this is the exact area. But if we want to do the nearest tenth, then you're going to go ahead in your calculator and do 25 times pi, get a decimal, and subtract 50. That should end up 28.539, etc. Nearest tenth would be 28.5. square inches. So again, depending on your purpose for finding the area, or if it says leave in terms of pi or round to the nearest tenth, one of these would be your answer. Okay, why can't I say 25 pi minus 50 is negative 25 pi? You kind of treat pi like a variable, right? If you wouldn't do 25x minus 50, if you wouldn't turn that into negative 25x, you wouldn't do it with this either, okay? Those are unlike terms because one has pi, one does not. If you want to combine them, you have to turn pi into a decimal. All right, let's do another one because they aren't all that pretty. So this is going to be 120 degrees, and that's what we're finding. So area of the sector minus area of the triangle. The sector is the easy part. So what fraction are we looking at? So 120 over 360 simplifies to a third of, what's the area? 36 pi, and a third of 36 is 12. So 12 pi is this entire area. Now here's where it gets messy if you don't know which direction to go. Now on the last one, we were able to do 1/2 the base and the height because we had a right triangle, okay? With this one, this is not a base and a height, right? You need the base and the height to be perpendicular. Now, I believe one of the ways we've done it in the past, and don't write this down because this is not, if I were to put the height in, that makes each of these 60. I would have to use either a special right triangle or trigonometry to go about finding that length and that length, right? Kind of ugly. And actually, that's what we used to do. And then it dawned on us that that really is not necessary because that's a radius and that's a radius, which means this is 6, right? And isn't this a side angle side situation? So we can use that formula, area is 1/2 BC sine of A, which is much, much easier than having to use trig or special right triangles to find a base and a height, right? Now remember, again, if you've got that right angle, then just do the base times the height. That's super easy. But here, the area of that triangle, so it's 1/2 BC sine of A. Nice thing is B and C are both the same. Okay, so it'd be 1/2 6 sine of 120. So if you use your calculator, this is 15 point, I would probably do hundredths on this because we're going to have to round here and round there. So 15.59 and 12 pi is 37.7. and then you can do your subtraction. So 22.11 square meters. I'll tell you, when we taught this in the past with having to use special right triangles and trigonometry, although it is more practice for you guys on that, was kind of a nightmare. And then we all realized that it'd be much easier to use the sine formula for those because the radius is the same. So you've got a side angle side situation.